Hi everyone, it's Math with AUB. I'm here with another frame based on the question of first year. First year. Question number 1 goes as if A and B are disjoint. Disjoint are sometimes known as mutually disjoint. Mutually disjoint. Let me draw their Venn diagram. If the sets are mutually disjoint means they are not overlapping. Mutually disjoint means not overlapping. Mutually disjoint means not overlapping. Intersecting means their intersection is null set. If two sets are mutually disjoint, then their intersection is equal to null set. Null set. Null set can be written either in that form or in that form. To write empty set like this, it is incorrect. Incorrect. Empty set is also known as void set. Void set. This is the first possibility when both sets are mutually disjoint. If they are not mutually disjoint, they might be partially overlapping. Partially. This is A, this is RB. This area is known as A intersection B. In that case, intersection is not equal to null set, means it is overlapping. First possibility, mutually disjoint. Second, partially overlapping. The third possibility, either of the set is subset of another. This is A, this is B. In that case, A is subset of A is a proper subset of B. A is proper subset of B. Or it might be the case B is subset of A. These are the possible diagrams for two sets. Either they are mutually disjoint, partially overlapping, either of them is subset of another. In that case, A is subset of B, and in that case, B is subset of A. How to count their numbers or elements or cardinality of a finite set? It is given by number of elements in A union B. Union shows the total. Union shows the total is given by individual elements of A plus B minus overlapping portion. A and B. Take this Venn diagram. Look at this. That is the portion. It has been counted in A as well as in B. That is the portion. Such type of element, they are present in both A and B. They have been counted in A as well as in B. Then we have to subtract them in order to get balance. This formula is valid either for these two as well. In that case, nothing is intersection. 0 is the number of element that present to overlapping this one. That is the number of elements to be counted for anyone. Total A, in B, in overlapping. For three sets, it is a good formula to be understood. A union B union C for three sets. It's equal to number of elements in A, number of elements in B plus number of elements in C. Then we have to subtract their pairwise intersection. Subtract A intersection B, B intersection C, A intersection C. Then we have to restore the overall intersection of all these three sets. A intersection B intersection C. This is the formula for involving three sets. Whether they are overlapping, mutually disjoint, two overlapping, three, whatever the case is. This is the way to count their cardinality of the finite numbers for two sets, for three sets. Okay, let's move to second question. 1 minus 1 iota minus iota forms a group, or it is closed under. It is a group closed under addition, subtraction, division, multiplication. Addition, subtraction, division, multiplication. Let me give you good overview about iota. Iota is equal to minus 1. Iota square is equal to minus 1. Iota cube can be written as iota square into iota. Iota square is minus 1. Minus 1 times iota. So iota cube is equal to minus iota. Similarly, iota power 4 can be written as iota square times iota square. Minus 1 times minus 1, it is equal to plus 1. Okay. These are the four values: 1, minus 1, iota minus iota. Whatever the power of iota is, it always results in 1 minus 1 iota minus iota. If our power is odd, it results in iota or minus iota. If power is even, then it results in 1 or minus 1. If the power of iota is odd, it always results in iota or minus iota. If the power of iota is odd, it always results in iota or minus iota. If the power of iota is even, it always results in 1 or minus 1. 1 or minus 1. Let me give you a good identity regarding this. Any four consecutive powers of iota results in 0. Their sum results in 0. Iota raised n plus 1 plus iota raised n plus 2, iota raised n plus 3, iota raised n plus, iota raised n plus 4. It always equal to 0. Any four consecutive powers of iota, always their sum always results in 0. How? Let's see. Taking iota power n common, what remains from here? Iota power 1. Here iota square. In that case, iota cube. In that case, iota power 4. Okay. Iota raised n, no idea about it. Whatever the case value of n is, it must be a real, not imaginary. Okay. Iota square means minus 1. Iota cube, we have already mentioned, minus iota. Iota 4 means 1. Positive, negative, negative, positive, cancel. Iota raised n times 0 is equal to 0, is equal to 0. A tiny background for iota to understand such questions. 1 minus 1 iota minus iota forms a group under multiplication as well as division. Multiplication as well as division. It is closed. Let's see how to prove closure property. That is the way of writing closure property. A star B belongs to G for all AB belongs to G. Closure property, binary operation, closed under binary operation, closure property are closed under. That is the way to write closure property. Closure property. 1 minus 1 iota minus iota. 1 minus 1 iota minus iota. Multiply 1 minus 1 iota minus iota. Okay. Multiply with minus 1, minus 1 1 iota minus iota. Let me write clear property for you. A star B belongs to G for all, for each AB belongs to G. Okay. Multiply with iota. Iota with 1 iota minus iota. Iota square means minus 1. Minus iota square means positive. Minus iota, positive iota, minus iota square means 1. This is minus 1. This is closed under multiplication. This set is closed under multiplication. It forms a group under multiplication. Check their elements. 1 has inverse 1. If we reciprocal 1, it is always 1. Reciprocal of minus 1 is always minus 1. Okay. Reciprocal of iota, 1 upon iota, it is equal to minus iota. Okay. And reciprocal of minus iota is positive iota. So inverse of 1 is 1, inverse of minus 1 is 1, inverse of iota is minus iota. Iota inverse is equal to minus iota, and minus iota inverse is equal to iota, is equal to iota. Similarly, we can prove, we can check with the division. It is closed under multiplication. Now what about division? Let's check. 1 minus 1 iota minus iota. 1 minus 1 iota minus iota. 1 divided by 1, 1 minus 1 iota, it's minus iota. 1 divided by 1, minus 1 divided by 1, negative 1, it's positive 1. Iota divided by 1, minus iota, it's positive iota. What about this? 1 divided by iota. Let's see. 1 divided by iota. 1 divided by iota. 1 divided by iota. Rationalize. Minus iota, minus iota, it will be minus iota over minus iota square. Minus iota, minus time minus 1. It results in minus iota. So reciprocal of 1 over iota is iota. So it is a minus iota. 1 upon iota is equal to minus iota. Okay, cool. And minus 1 upon iota, it results in iota. Iota divided by iota 1, minus iota divided by iota, it is equal to minus 1. Similarly, minus 1 upon iota, iota. minus 1 upon iota, iota. Minus 1 upon iota divided with minus iota, it will result in 1 divided by minus a positive iota, negative iota, it is negative 1 and it is our positive 1, positive 1, positive 1. So it is closed under multiplication as well as division. In reality, it is a cyclic group. It is a cyclic group. It is a cyclic group whose generators are plus minus iota. So this can be generated from iota or minus iota in case of multiplication as well as division. So it is closed with respect to multiplication as well as division, means both A and C. Both A and C. Moving to next question, that is a simple one. Omega raised 14 plus omega raised, how much it is? Omega 4, omega 16, I think. Omega raised 4, to me that is iota 16. That's iota 16. Okay. We are already familiar from the identities of omega. The sum of cube roots of unity, the sum of cube roots of unity is equal to 0, and their product is equal to itself, means 1. So omega 14 can be written as omega cube type 3 times 4, 3 4 the 12. What remains 2? 3 4 the 12, 12 plus 2, 14. And what about this? 3 raised 15 times omega. So it's equal to 1. It's equal to 1. 1 raised 4 times omega square, 1 raised 5 times omega. That's our omega square. That's our omega. From this, we can find value of omega plus omega square. It's equal to minus 1. It's equal to minus 1. It's equal to minus 1. And it also forms a group under multiplication. Let's prove 1 plus omega square, 1 omega square, 1 omega square, multiply omega square, omega and omega square, omega cube means 1, omega square and omega cube means 1, omega 4 means omega cube times omega, 1 into omega, so result is omega. So this forms a group under multiplication where inverse of 1 is 1, inverse of 1 is 1, inverse of omega is omega square, and inverse of omega square is omega. I have given you extra mile in case of omega. Another good question based on quadratic equation, that is 2x square plus kx, 2x square plus kx plus 16, 2x square plus kx plus 16. If x is equal to 4 is one root, find the other root. Find the other root. Simple way, having no ability, put x is equal to 4 here. 2 4 square plus k times 4 plus 16. 4 square means 16. 4k plus 16 is equal to 0. 32 plus 4k plus 16 is equal to 0. 32 plus 16, it will result in 48. Move them to right hand side, minus 48. So k is equal to negative 48 divided by 4, k is equal to minus 12. Put here and then find the other root, that is 2x square minus 12x plus 16. 2 is the common factor. We have x square minus 6x plus 8 is equal to 0. For to that, Milton breakup, we have x square minus 4x minus 2x plus 8 is equal to 0. X common, x minus 4 minus 2, x minus 4. So one root is x minus 4, the other is x minus 2. X is equal to 4, it is given to us. The other root is x is equal to. The other root is x is equal to. It is a simple method, but taking time when you have little ability. When you're a beginner, if you utilize the little bit concept of quadratic, our equation is 2x square plus k times x plus 16. is equal to 0. 1 root is 4. We are familiar from the formation of quadriculation x square minus sometimes the root plus product. Sometimes the root product. If we utilize this one, it is going to be our smart word. Divide by 2, we have x square plus k square 2x plus 16 over 2 means 8 is equal to 0. Now that is equal to product of roots. Product of roots is equal to 8. Roots are alpha and beta is equal to 8. One root is given, either take it alpha or beta, put here. 4 times beta is equal to 8. So beta is equal to 8 over 4 means 2. That's 2. That's the smart work. The previous one, the linger on method, when person has little ability or a beginner. Okay, cool. Tiny concept 5. A is equal to A transpose. That's the definition of symmetric matrix. Everybody is familiar. This question becomes a wonderful if it is given to you. A minus A transpose is equal to 0 or A transpose minus A is equal to 0. Then it is something special. A simple identity, a little bit shuffled. They are going to work wonders for you to get you headache. A minus A transpose minus A, they are also equal to 0. And let me give you an idea about symmetric matrix. A transpose is equal to negative times A. It is a definition of skew symmetric matrix. Skew is symmetric. If it can be written as A transpose plus A is equal to 0, then it also works wonder for us. Okay, cool. Question number 6. We have a boy has 9 tickets numbering 1 to 9. Tickets bearing number 1, 2, 3, 4, 5, 6, 7, 8 and 9. Okay. He picked 3 tickets. Find the total number of ways such that the tickets picked are first odd, then even, then odd. To pick first ticket, we have 5 possibilities because we have 5 odd numbers 1, 3, 5, 7, 9. For first possibility 5. To pick an even number, second time we have 2, 4, 6, 8, 4 choices. Either 1, 3, 5, 7, 9, one odd number has been picked. Now we have for odd 4 choices as well. 16, 5 the 80. 16, 5 the 80. So we have 80 choices to select from tickets numbering 1 to 9 in the order odd, even and odd. Odd, even and odd. These are tickets. One ticket has been picked. It has been picked. Never be replaced. Okay. So 80 is the right option in that case. A good question. MCQ number 7. A wonderful MCQs from matrices. Wonderful. Let's see how. A matrix having order 3 by 3. A square matrix. A square matrix order having 3 into 3. And having determinant is equal to 5. Determinant is equal to 5. Then the value of 2a times a, the determinant of 2a times the matrix, determinant of this one. It's very careful. Let's see. Take any 3 by 3 matrices. A11, A12, A13, A21, A22, A23, A31, A32, A33. That's our 3 by 3 having determinant is equal to 5. Determinant equal to 5. If we multiply 2 with the matrices, 2 with the matrix, it will become 2 times A1, 2 times. That is the way of multiplying a scalar to a matrix. That is the way of multiplying a scalar to a matrix. Okay, now find its inverse. Find its determinant. 2 times A11, 2 times A12, 2 times A13, 2 times A21, 2 times A22, 2 times A23, 2 times A31, 2 times A32, 2 times A33. Now for determinant, we have to, from determinant, we have to take common either row wise or column wise. 2 common from this row, 2 from this, 2 from this, means 2 into 2 into 2. What remains? The original matrix determinant A11, A12, A13, A21, A22, A23, A31, A32, A33. So 2 to the 4, 4 to the 8, and the value of this determinant is given to us. 8 5 the 40, 8 5 the 40, 8 5 the 40. That is the way to multiply a scalar to a determinant. Look, 2, what is the order of matrix? Order the given constant times determinant. Determinant, what is our constant? 2 is our constant. 2 is our constant raised order times determinant. 2 raised order times determinant. 2 raised order times determinant. What is our order? 3 by 3. 3. 2 raised 3 times mod A. Mod A means determinant is given to us 5. 8 5 the 8 5 the 40 is the answer. 40 is the answer. Any scalar multiplied to a determinant 2 times the order of the matrix, order of the determinant, order of the matrix, order of the matrix, order of the matrix. And we are familiar, determinant of a square matrix is always possible. Determinant of a square matrix is possible. A good MCQs to me. Any scalar that is going to be multiplied, raised its order 3 times A. Okay. And I have given you the lengthy proof, subjective proof as well. Okay. So 40 is the answer in that case. Another good question from sequence and C's. We have given the sum. We have given the sum of an AP and we are asked to find 6 term. Sum of the series Sn is equal to, what is our Sn? N square minus 3n. Find its 6 term. 6 term sum. Let's open up what is sum. S1 means sum of first term. S2 sum of first 2 terms. S3 sum of first 3 terms. S4 sum of first 4 terms. S5 means sum of first 5 terms. Similarly, S6 is A1, A2, A3, A4, A5 plus A6. Now, I have given you a good idea. Now, just understand. We are asked to find 6 term. 6 term. 6 term. If I write S6 minus S5, I am going to get 6 term. S6 means A1, A2, A3, A4, A5, A6. If I cancel them out, what remains? The S6. S5 means A1 plus A2 plus A3 plus A4 plus A5 plus A6 minus A1 plus A2 plus A3 plus A4 plus A5. Cancelled out except A6. A6 is equal to A6. That is the background that we are going to use in that question. We are asked to find 6 term. It's really very cool. 6 term is given by S6 minus S5. S is given to us, put 6 here, it will become 6 square 3 times 6 minus S5, put 5, 5 square minus 3 times 5, 36 minus 18, 25 minus 15. So we have 18, 25 minus 15 is 10. 18 minus 10 is 8. 18 minus 10 is 8. So 8 is our option in that case. 8 is our option in that case. Don't forget to utilize this, We have given some. If we would have been asked to find 11th term, we can write S11 minus S10. If we are asked to find A117, then I would have written S117 minus S116. 160. Okay. Moving to next question. Limiting the frames time. The arithmetic means between 15 and 17. Insert 3 AMs between 15 and 7. We are asked to find 3 arithmetic mean 15, 15 and 7. Look at this. 15, first arithmetic mean, second arithmetic mean, third arithmetic mean, and 7. If we utilize option, we can easily manage. Look at this. This is going to be our answer: 15, 13, 11, 9 and 7. Look at this. From options, for arithmetic, their difference must be same. 10 minus 13, it's minus 3. 4 minus 10, it's our minus 6. 9 minus 13, we are going to have 4. 11 minus 9, we are going to have 2. What about this? 30, 11, the difference of 13 and 11, 2. The difference of 11 and 9, 2. And in that case, difference is 3, difference is 2. So, it has the same difference. It has the same difference. From common sense, we can say that 13, 11, 9 and 13, 11, 9 are the required arithmetic means. Okay, how to find them? Let's see. This is our first term. 15, that's our fifth term. First term, that's our fifth term, 7. Okay, utilize fifth term and find D. A(n) is equal A plus n minus 1 times D. A5 is, what is our A? 15. N is 5 minus 1. D we have to find out. Fifth term is 7. 7 is equal to 15 plus 4D. Shift 15 here. 7 minus 15 is equal to 4D. 7 minus 15 means minus 8 is equal to 4D. Minus 8 over 4. So D is minus 2. D is minus 2. Keep on adding D. What the formation rule for arithmetic? That is A plus D, A plus 2D, A plus 3D, A plus 4D and so on. Keep on adding D or subtracting D. A minus D, A minus 2D and so on. So add D here. You will get 15 minus 2, 30. 13 minus 2, 11. 11 minus 2, 9. 9. That is the one way, subjective way to get to the arithmetic means. There is another tremendous method to get direct arithmetic means, whatever you want. Let's see and find out what are the more than one arithmetic mean. More than one arithmetic mean. These are the formulas for first arithmetic mean, Na plus b over n plus 1. Second arithmetic means, keep on diminishing n, increasing the coefficient of b. N minus 1 times a plus 2b over n plus 1. Similarly, a3. Third arithmetic means, keep on diminishing 1, adding 1. N minus 2 times a plus 3b over n plus 1. Fourth arithmetic means, n minus 3 times a 4b over n plus 1. And eventually we have to arrive at shift n here. It will become a nth and last a plus n times b over n plus 1. That is the way to find any arithmetic means. Our question is, insert 3 arithmetic means between 5 and 7. And our answers are 13, 11 and 9. So let's find third arithmetic mean direct. A3. A3 means n minus 2 times a plus 3b over all n plus 1. And the number of arithmetic means to be inserted. And the number of means to be inserted. Number of means to be inserted, that's 3. 3 minus 2, what is A? A is the first term, 15 plus 3. What is B? The last term, 7 over 3 plus 1. 3 minus 2, 1. 1 times 15 plus 3 times 21 over 4. 15 and 21, they are 36. 36 divided by 4, it's our 9. And 9 is our third arithmetic mean. Similarly, we can find the first one, second one direct. That look, okay, find second one. A2, n minus 1 times a plus 2b over n plus 1. N is 3, minus 1 times a is 15, plus 2 times b is 7 over 3 plus 1. It will become 2. 2 times 15 plus 2 times 14 over 4 means 30 plus 14, 44 divided by 4 11 is our answer. 11 is our answer. That's second arithmetic. That is the way this formula to be utilized. Tremendous to get direct arithmetic mean first, second, third, fourth, fifth, sixth without calculating anything. Just putting direct in the formula. First, n times a plus b overall n plus 1. Keep on decreasing, diminishing the coefficient of a and keep on increasing the coefficient of b in same fashion. Subtract 1, add 1. Subtract 3, 3 plus 1, 4. Subtract 2, 2 plus 1, 3. Subtract 1, 1 plus 1, 2, and so on. Okay, I hope you have followed me in that case. So our last question, based upon the probability, we are familiar, the probability of any event lies from 0 to 1, inclusive. 0 means not possible, no chance to occur, 1 to be exact. The probability density is 0 is less than p, p is less than or equal to 1. That is the probability density function. We have given the probability of an event A is 1 over 3. Similarly, probability of B is also 1 over 3, if I am not wrong. And probability of overlapping portion of A and B, A intersection B, is equal to 1 over 9. Then we are asked to find the probability of A union B whole complement. Whole complement. We have just utilized the cardinality of 3 sets that I have given you. I have shared with you n times A union B. Number of elements between A and B in A and B is n times A plus n times B minus n times A intersection B. In case of probability, write here P instead of n, P, that's P. Okay, cool. What is probability of A union B? We have no idea. We are asked to find probability of A union. Probability of A given to us 1 upon 3. Probability of B also 1 upon 3 and probability of overlapping portion 1 upon 9. Okay, 2 over 3 minus 1 over 9. LCM, 9 is the LCM. 6 minus 1, it is 5 over 9. 5 over 9. 5 over 9. And we are familiar from the complement law, probability of A union B plus probability of A union B complement is always equal to 1. Probability of any event and its complement always results in 1. Probability of any event and its complement always results in 1. It's given to us, we have just found out probability of A union B is 5 over 9. We are asked to find probability of A union B whole complement and lump sum is equal to 1. Shift 5 over 9 over here. We have probability of A union B whole complement is equal to 1 minus 5 upon 9. So 4 upon 9 is the probability of A union B whole complement. You can find direct, that's probability of A union B. Utilizing complement law, subtract this one from 1. 1 minus 5 over 9. 1 minus 5 over 9, the result is 4 over 9. 4 over 9. That's my tiny effort, guys, to prepare you for the upcoming exams. It's all by itself. Next.